Hello. I hope you're having a great day, and I hope you're getting along well with the online learning. In Chapter 6, we really looked at trig functions and understanding trig functions and understanding kind of where they came from, how to work with them. In Chapters 7 and 8, we're going to take a look at kind of some things that we can do with trig functions, and we kind of start treating the trig functions more as an object and then kind of filling in from there. So the first section here, we're going to look at how to simplify trig expressions and really look quite a bit at Pythagorean identities. So let's take a look at what a Pythagorean identity is. So you're familiar with this picture. It's come up quite a bit. If the radius is 1, then sine theta we can think of as y over r. It just really becomes y. And so this distance here can be thought of as sine theta, and this isn't a new idea. And cosine theta, similar thing happens when r is 1. Cosine, the x value here, is just cosine theta. And if we think of this as a right triangle, we know our Pythagorean theorem. We can think of sine squared, or sine theta squared, whatever that distance is, plus cosine theta, whatever that distance is squared, equals 1 squared. Or mathematicians kind of got, at least this is my assumptions, tired of writing these parentheses each time. And so we can just use this kind of abbreviation, sine squared theta plus cosine squared theta equals 1. And this is the Pythagorean identity, or at least one of them. And so that takes us, you could see they used x as the variable here instead of theta, but it's the same thing. One more time I'll point out, this isn't actually squaring the word sine. It's actually taking sine of an angle and then squaring it. It's just an abbreviation to write this. Now, you'll notice here in this box there are 9 different Pythagorean identities or equivalent forms. I'm really going to encourage you just to memorize this one and then be able to find the rest from here. And that's what I'll show you in this video and the next. So if you know that this is true, to come up with this, it's just a matter of subtracting cosine squared from both sides. Hopefully you see that. But now I have sine squared of x equals 1 minus cosine squared. And similarly, if you want to get cosine squared by itself here, you could just subtract sine squared from both sides. This is gone. You're left with cosine squared x equals 1 minus sine squared. So however that works best for you. But we're really going to use this quite a bit in the future. And something I'll point out is this is true all the time, no matter which angle I'm working with. So any triangle on this circle, this will be true. And even a point like right here, where I have 0, negative 1, that's going to be true as well. 0 squared plus negative 1 squared equals 1. And so it's called an identity because it's true for any value of x or any value of theta there. The other thing I want to point out is this is not true for just sine and cosine. There is no identity that says sine x plus cosine x equals 1. So that is not true. You should not ever do that. Only for sine squared and cosine squared. So hopefully that is helpful. The main takeaway is just recognizing that this identity exists, and that it can be rearranged and used